All right, let's just dive right in. And I mean that literally. We are about to imagine taking the ultimate one-way trip, a journey past the point of no return and straight into the heart of a black hole.
You know, Lewis Carroll really nailed the feeling of a long, strange fall. Alice's trip down the rabbit hole, it's probably the best analogy we have for this journey. It's a descent into a place where all the familiar rules of reality just start to, well, they start to bend.
And that's it, right? That's the billion-dollar question. What would you actually experience? What would you see? And, let's be honest, how does it all end? Let's find out.
To make this whole thing feel a little more real, let's frame it as an actual mission. Imagine you're volunteering. You're sitting down for an interview to join the very first black hole diving research group.
The interviewer doesn't waste any time. They get right to the heart of it. This is a mission for pure discovery. You can never come back. And once you cross that line, you can never, ever send a message home. So, why on earth would anyone sign up for this?
The answer isn't about fame. It's not about money. It's just about that fundamental human need to know. To finally answer the question, what if? Even if you can never tell anyone the answer. And you know what's crazy? In this thought experiment, over a quarter of all qualified people volunteered, knowing full well it was a one-way trip.
So when they ask what kind of complex, high-tech atomic clocks you're going to bring, the answer is so simple it's almost profound. Our wristwatches. Because inside the warped reality of a black hole, the only time that truly matters is your own. That steady tick-tock on your wrist becomes your anchor, and that idea is going to be incredibly important later on.
Okay, now here's a twist I bet you didn't see coming. Just because you can't send messages out doesn't mean you're completely cut off from the universe. The event horizon, it turns out, is a one-way street.
This is just incredible. You could literally be falling toward the center of a black hole while watching the latest news reports from Earth. It proves that the event horizon really is just a one-way membrane. Information can fall in, no problem. It just can never, ever climb back out. All right, so now we get to the most famous part of a black hole, right? The event horizon. This is the boundary line. This is the true edge of the abyss.
And this is where we hit the central, mind-bending paradox of general relativity. For you, the diver, crossing the event horizon is, well, it's kind of boring. It's a total anticlimax. Your wristwatch keeps ticking just fine. There's no giant flash of light, no bump in the road. You just sail right through. But for your friend watching from a spaceship far away, they see your clock slow down, they see your image get redder and dimmer until you seem to freeze right at the edge forever. Two totally different realities describing the exact same event.
So if you don't notice anything special, why is it the point of no return? To get our heads around that, we need a better way to picture gravity.
I want you to imagine that space isn't just an empty, static stage. Imagine space itself as a river, and at the center of the black hole, there's a giant cosmic waterfall. Now, this isn't just some cute metaphor. It's a really powerful way to understand what Einstein's theories are actually telling us. Gravity isn't a force pulling you in. It's the very fabric of space itself that's moving.
So far away from the black hole, the river is calm. But as you get closer, that current starts to pick up speed. And right at the event horizon, the river of space-time is flowing inward at the speed of light. Now think about that. Even if you were a beam of light, the fastest thing in the universe, and you tried to swim back out, the current is just too strong. You'd be swimming in place. And once you're inside, the river itself is flowing inward faster than the speed of light. Space is moving faster than anything can move through space. Escape isn't a question of having a bigger engine anymore. It's physically impossible. The direction we call out just doesn't exist.
So you've crossed the line. Escape is off the table. What now? Is that it? Game over? Nope. Not even close.
This is the part that absolutely blows my mind. If you dive into a supermassive black hole, like the one at the center of our own galaxy, your wristwatch could keep ticking away for up to 20 years before you reach the center. 20 years of life inside a black hole.
So what do you do with those 20 years? Well, your research group could actually function like a real scientific community. You'd still get news from the outside world, you could run experiments on the completely bizarre physics all around you, and you could even publish your findings in a little journal just for the other members of the diver team. The only unbreakable rule? Time. On your watch, only ever moves forward.
But of course, all journeys have to end. After years of this strange existence, floating through the interior of a black hole, your final moments arrive with unbelievable speed.
And it ends with the famous process of spaghettification. It has a goofy name, I know, but it is brutally literal. The gravitational pull on your feet becomes so much stronger than the pull on your head that your body is stretched and elongated and squeezed into a thin stream of atoms.
We can actually calculate the exact moment you'd start to feel, well, uncomfortable. It happens when that stretching force, that difference in gravity between your head and your feet, becomes equal to the normal pull of gravity we feel right here on Earth.
And from that very first moment of discomfort, how long does the end take? Less than a quarter of a second. The source actually calls this the ouch time. And what's wild is that it's the same for every single non-spinning black hole in the universe. After a journey that could last for 20 years, the end is mercifully and just shockingly quick.
Which leaves us with one last, really deep question. This entire journey is built on predictions that we can never truly check from the outside. So if a community of researchers goes in, confirms all our theories are correct, but can never ever share their results with the rest of humanity, does that knowledge still count? Is it still science? That's something to think about.